HAART is an aortic repair technology under development by BioStable Science and Engineering, Inc. The technology includes the HAART 300 tricuspid device designed for patients with tricuspid valve leaflets with dilated aortic annuli demonstrating aortic valve insufficiency, also known as AI. The HAART 300 device may also be used for patients requiring an aortic root replacement or valve sparing procedure. The HAART 200 bicuspid device is for those patients with diseased and insufficient bicuspid valve configurations. The healthy human aortic valve regulates flow from the left ventricle of the heart to the body during systole via full opening of the valve leaflets. During diastole, the valve leaflets close to eliminate or minimize blood flow backward through the valve into the left ventricle. Some patients suffer from dilation of the aortic valve annulus and aortic wall, allowing blood to flow back into the ventricle, resulting in AI. The HAART technology is designed to be used in AI patients with or without valve cuspal prolapse. The HAART technology includes an instrument for selecting an appropriate aortic repair ring. After aortic valve exposure, the sizer ball is placed behind the right coronary leaflet. The length of the free margin is evaluated such that the leaflet insertion into the aortic wall falls within the area of crosshatch marks on the sizer ball. This provides the proper size of the device to be implanted. The HAART 300 device, mounted on a holder, is placed through and below the aortic valve leaflets, with each device post being placed underneath each aortic valve commissure behind the leaflet attachment junctures with the aortic wall. After placement of the 3 post sutures, the holder is removed from the frame. Additional sutures are placed behind and through the annulus at the base of each leaflet. These sutures are looped around the base of the ring and brought back out behind the leaflet, where each suture is tied off using polyester pledgets to secure the ring in place. Through the resizing, reshaping, and stabilization of the aortic annulus with the HAART 300 device, the aortic valve is once again competent with minimal regurgitation. In AI patients with accompanying aortic leaflet prolapse, the HAART ring is implanted to correct the dilation, followed by correction of the prolapsed leaflet height via plication sutures placed in the prolapsed leaflet free edge, raising the free edge, resulting in improved leaflet coaptation. Once the HAART device is implanted and the leaflet prolapse is corrected, the aortic valve is once again competent. The HAART 300 device is also designed for use in aortic annulus and root stabilization in root replacement and valve sparing procedures. Root replacement is required when there is dilation or an aneurysm in the aorta, but the aortic leaflets are relatively undamaged. The HAART 300 is sized and implanted in the same manner as described for AI patients. After the diseased aorta is removed and the ring is sutured in place, an appropriate size polyester vascular graft is sutured over the stabilized HAART ring and leaflet structure on one end, and the aorta on the other end. The repaired valve with its replaced diseased aorta is once again competent with no regurgitation. In addition, a HAART 200 bicuspid ring has been developed for patients with congenital bicuspid valves, or valves where 2 of the 3 leaflets have fused, and the valves demonstrate AI. A sizer designed specifically for use in bicuspid patients measures the leaflet free edge length of the larger leaflet or the 2 fused leaflets. The appropriately sized HAART 200 ring is implanted in the same procedure as described for the HAART 300 tricuspid device. For bicuspid leaflets that are not a 50-50 valve diameter split, additional leaflet surgical procedures are conducted to reconfigure the valve with 2 equally sized leaflets. Once the ring is in place and the appropriate leaflet alignment is established, the valve is once again competent with no regurgitation.